So Thom and I are part of Team D of the app, which is called Understanding Decision Making. And it's part of the app which focuses on trying to understand, enrich, formalize decision making for autonomous agents. In particular, we are working on trying to formalize this type of decision making for agents that act in environments where there is uncertainty, so when not everything is clear or crisp. And as a more practical example, we're going to talk about a paper Thom and I and Professor Alessandro Abate and Giuseppe De Giacomo developed, which has been featured at one of the most prominent AI conferences. And yeah, Thom, I think, can take it from here and talk about this paper.
Yeah, so what we do in this paper is essentially we want to make robust decision making less conservative. So as a very concrete example, suppose that you are designing an autonomous drone that needs to be able to fly through uncertain weather conditions, right? One thing that you can of course do is reason robustly against all these different weather conditions. So you're analyzing this drone and you want to prove that even under the worst case weather conditions, the drone is still able to fly safely, right? But this is, even though it's safe, it's very conservative, right? Because in practice, these weather conditions, they don't really respond to what the drone's doing, right? The weather conditions, they don't really change in reality as a function of how we control the drone. And that's essentially the challenge that we want to overcome. We want to make this less conservative. And the way that we do this is by bringing together ideas from game theory and AI planning together with formal methods in order to develop algorithms with refined optimality criteria, basically, that lead to these decision-making methods that are less robust. And I think it's a very cool and interesting collaboration where Giuseppe De Giacomo has a lot of expertise in AI planning and game theory, whereas Alessandro Abate is more an expert also in formal methods. And yeah, I think it was a very nice project also for Francesco and me to start working together and really be productive within the hub.
Yeah, I think that's also very interesting how the hub is trying to, merge all of these computer science subfields such as, formal methods, AI planning, stochastic reasoning, and so on and so forth. So yeah.
Yeah, so my research, very broadly speaking, is about algorithms for decision making under uncertainty, right? So these algorithms are needed in many different domains, such as control of autonomous systems, of autonomous drones, or self-driving vehicles. And in particular, with the rise of AI, the complexity of these systems is growing and growing even further, right? So it becomes even more difficult to make these decisions that are verified to be safe and reliable for these very complex systems, in particular when they embody all sorts of AI models, right? So I think within the hub, one of the things that I like to work on are to think about how we can develop novel algorithms for decision making that we can use to prove that AI-enabled systems are safe and reliable and can therefore be used among humans in the real world.
Right. Similar to Thom, my focus on research is about decision making, specifically sequential decision making, which is often referred to as automated planning. My focus within the app is to try and take all of these techniques from automated planning, which are considered now classical AI, which provide some safe and nice way of solving problems, finding the best course of action to achieve someone's goal, for example, and try to enrich this kind of decision making with these new emerging technologies, which are, of course, very powerful, but also sometimes, as Thom mentioned, they don't come with any kind of guarantees or insurance. So we want to use these new ways of reasoning, which are very powerful in general, and try to fit them within the most standard way of thinking about AI, which was safe and reliable. So I think that this is true for most of the computer scientists I know, and all of us we're trying to create better understanding of these new emerging technologies that have been flooded the world, that have been flooding the world, such as LLMs or whatever keyword you hear around. So as a broader research impact, I would like to make sure that when technology is adopted or used by the general public, then that technology itself is either understood by the public itself or is confined and encapsulated in a well-defined environment such that their use is safe for the public. For example, with this new, of course, emerging technology, there is a lot of problems. We are just using technology that people don't really understand and may cause troubles or problems along the way. We now are using machines as we did 20 years ago, but they do not give correct answers anymore. We have uncertainty in the answer given by LLMs, for example. So, yeah, I think what's very important for us computer scientists within the app and also outside the app is to provide technology which can be of actual help to people, reliable, and that can be understood and used appropriately. And to do that, I plan to delve deeper in these neurosymbolic AI or these logic AI based approaches that allow the user to still have a very powerful tool on their end, but be able to trust them 100% of the time, like we used to with calculators, for example. So yeah, that's my broader objective.
So for me, I think my long-term research goal is essentially to close the gap between the complexity of the systems we build and those we can prove to be reliable. Right? This links back to also earlier in the conversation to algorithms for decision making. Right? We build very complex systems, maybe with AI, LLMs embodied in these systems. And that makes it very difficult to verify that they're really correct by construction, right? Or at least that we can quantify what is the risk of using such a system. And I think one of the areas that I'm very excited about and want to explore more is to merge rigorous statistical learning theory in these verification processes, right? Because classical verification, you could argue, is very much a model-based thing. You're given a model of some system, you have a property, a task that you want to verify whether the system satisfies it or not, and you run this through an algorithm, and the algorithm essentially outputs, yes, the system is correct or it's not, right? But these modern AI-driven systems, they're so complex and so huge that this model-based verification is not tractable anymore. It's just not possible anymore. And that is why I think one exciting area is about statistical verification, where we are trying to get, we want to make decisions or want to verify systems with a high confidence probability, right? And the interesting or the important bit is that we also want to quantify this confidence, right? We want to know what's the probability that the verification outcome that we got was wrong. And this is not easy in lots of cases, but I think it's a very interesting research direction and one that I'm excited about to work more on in the coming years.
Yeah. If I might add something, it's just I feel like we, as computer scientists, all of us within the app, we all are working towards this direction of understanding how information is manipulated and how we get the answer that we get, and we want to make sure that answers are not, unreliable, and just to make sure that the public, if something doesn't work, is not always good enough. You don't need to be lazy. You want to make sure that the tool you rely on are actually reliable and you can trust them. So right. I think this is also, we take this idea of generating reliable tools to our very specific, research direction, but this is the overall app goal also, right? Understanding the information, how data is treated, how, data is processed to make sure that whatever information manipulation we do will output something that we can trust.
Exactly, right. And maybe even to add one more thing to that. So one concrete technology in AI that's of course very popular is reinforcement learning, right? Essentially just learning from trial and error, which can either be also based on models or purely data driven. But reinforcement learning, it leads to very cool results. It has shown state-of-the-art performance in playing games of all sorts, Go and chess and these kind of games. But at the same time, there are also huge problems, right? Reinforcement learning, it's super data inefficient. It learns from trial and error. And also, it's by construction, because it does trial and error learning, it's by construction almost unsafe, right? And I think that for me, but I think that for Francesco, it will be largely the same perspective, is that we like thinking about how can we use logic and how can we use essentially more structured formal methods to try and improve these methods, to either make learning more efficient by exploiting structure in data or models, and possibly also how to make learning more safe and reliable.
Right, so it certainly has been a very interesting experience being part of a hub this large with multiple institutions and with very different people when it comes to background and also the way they do research. For me, it's been super cool working with other PDRAs that know basically completely different subfields of computer science, and where we were able to communicate on a topic that we kind of connected on, but on a very different perspective, the same topic, and basically try and communicate with these other people that belong to different universities maybe, and try to extrapolate their knowledge on that on a high level and try to merge this high level knowledge on key ideas that will result in an interesting research direction. So for example, I've been working with a couple of other PDRAs from Southampton on a topic which I didn't know much about, which was to use graph neural network to extrapolate information. And they were the expert in this field, while I was the expert on the basic underlying problem. And we were able to collaborate on a very high level, let's say, without going into details, but still managing to extrapolate important and relevant information that led to a very interesting result. So,
for me, it has been largely the same as what Francesco already says as well. I think for me personally also, collaboration within academia, within research, is also really one of the key reasons why I think it's such an amazing field to work in, right? I don't think there's any other area where you can find people from different areas that are so eager to collaborate and work on solving problems together and to interact and start collaborate. I think within academia that's really just a unique point, right? And in terms of collaboration, I think also what is very interesting from being part of the hub is that you can collaborate with other people and you can have different roles in these collaborations, right? As Francesco already mentioned, you can either be the expert on a topic, or you can, even if you're not the expert on a very specific topic, you can still very well collaborate together, right? If you're indeed the expert on the problem, or you know how to implement things, to write code in say Python and run experiments, then you can still very well collaborate. And I think the hub for me has been very helpful in stimulating this kind of collaboration, both within Oxford but also beyond and with the other hub partners. So Francesco and I, we both have a computer science background. We've done our PhDs in computer science, and I think what's very interesting and inspiring also from the hub that we have been exposed and have we been connected with many mathematicians, right? People with a pretty much different background. And I think for me, a new perspective was how relevant and important fundamental mathematics are actually within the context of AI and machine learning, right? And even though this is not always super close to the research that I'm actually doing, it is still an interesting perspective that I think has started to also shape, at least in some way, my own research agenda and the kind of research that I would like to work on. So I think as a starting postdoc, or started last year, I think one of the main transitions has been to think more about the type of research that I want to work on and the research agenda that I want to pursue. So I think this has been very, very important for me in that regard.
Yeah, I think I most agree with Thom. So as you mentioned, we both are computer scientists by trade, and being exposed to all of these people that work on the fundamental knowledge on how to use this emerging technology and really understand what's going on under the hood, we've been exposed to this idea of really trying and understand and formalize in our brain how to deal with data, information, and this led to, at least for me, to really ask different questions when tackling the same problem that I was tackling like maybe 3 years ago. And now I'm really looking at the same problems with a whole completely different perspective. And this is, a key point of research. Is also trying to change perspective, integrate new skills, and better understand the fundamentals of your field. And I feel like this intersection with mathematicians, topologists, really helped us. Yeah, me at least.
Right, and if I may add to that actually, so I think also another very good example of this is the collaboration that we started, right, Francesco and I, is that at the start, well, both of us have, even though we're both, we have done our PhD in computer science, also the two of us have really much of a different background, and it's also interesting, also challenging in a bit, sometimes even a bit frustrating, right, at the start to get terminology on the same page.
Yeah.
So starting this kind of collaboration is time consuming, right? It takes really many hours to converge on terminology, and when we say a certain thing, do we actually mean the same? Often not. But I think it has led to a very nice collaboration, and I think it's, as Francesco said, that it's really a key aspect of research, also to be able to shift these perspectives and also to learn these new perspectives and adapt to it. Yeah,
I completely agree.
So for me, I think since joining the hub, a lot of things have changed. So when you're doing your PhD, at least how it was for me, you're mostly thinking about the research that you're currently doing, right? The project that you're currently doing, you're working towards a PhD. And after finishing that, it becomes a bit different, right? Because you really start more thinking about what's my research agenda? What are kind of the larger challenges over the longer horizon that I want to work on? And I think for me, the past year, almost 1.5 years within the hub have been very important in shaping these ideas for me. A very important factor in this has been being connected with amazing people within the hub, both within Oxford and the other universities involved in the hub. And just by also chatting with these people, asking for feedback sometimes on, say, a grant proposal, that has been very interesting and important for me. Now for me, sadly, after 1.5 years, the time has actually already come for me to move to a next step and start another postdoc position, which is going to be in Aachen in Germany, where my goal is still to work towards or on the intersection of AI and formal methods. But so I look back at an amazing time here in the hub. I think it has been instrumental and very important in shaping my ideas and trying to figure out the path that I want to take in my academic career. Yeah.
Yeah, for me it's mostly the same. So as I was saying before, I moved from the US back to Europe. I mean Europe, yes, to the UK, and then once I started in Oxford at the app, it immediately was a different environment, at least for me. So a lot of support from advisors. In our case, Alessandro and Giuseppe, and also a lot of support from other PDRAs. It was, I think, the most important thing for this aspect for me is whenever we meet with other PDRAs for app events, after the more research-based topics, after we discussed math and computer science, we all gather around for a beer or whatever, a drink, and we discuss and we talk for hours about how we feel about academia, what is the next step, what are our next directions. And it's both comforting and also super interesting to hear that most of other PDRAs have shared the same problem that you have, and also most of them have solutions to those problems, So the app really helped me understand the broader sense of community that academia has to offer, and it really shaped me in the sense that now I really look forward for the next academic job, hopefully, and to bring this sense of community within other apps, maybe, or within Oxford or within any other university.